Hey friends, welcome to the YouTube channel All About Electronics. So if you have followed the previous videos, then we have discussed the various aspects of the amplitude modulation. So in this video, we will see the different techniques for generating this AM wave. Now there are three different ways by which we can generate this AM wave. The one is using the analog multiplier, while the second technique is using the nonlinear device. And this modulation technique is known as the square law modulator. Then the third method of generation is known as the switching modulator. So in this video, we will talk about the first two methods and we will learn about the switching modulator in the next video. So let's say this MT is the message signal and this AC cos 2 pi FCT or the AC cos omega CT is the carrier signal. So as we have discussed in the previous video, if we add some offset AC to this message signal and multiply that signal with the carrier signal, that is cos omega CT, then we can generate this AM wave. And here this multiplication can be achieved using the analog multiplier. Then the second way is using this analog multiplier, we can multiply the message signal and the carrier signal, and then this carrier signal can be added with this multiplied signal. Now usually during this AM generation, this message signal also gets multiplied by some constant factor. So typically the modulated output would be of this form. And if we take this AC cos omega CT outside, then we can write the same expression in this way. So this is another way to express this AM signal. And in fact, in many textbooks, this amplitude modulated wave is expressed in this format. And practically also, when we generate this AM wave using any of this method, then the message signal usually gets multiplied by some constant. So in such case, this expression is more meaningful. And here, this Ka is known as the amplitude sensitivity. So if we compare this expression with the earlier expression, then in the earlier expression, this Ka is equal to 1 over AC, right? So these are the two different ways by which the AM signal can be represented. Alright. So now let us see how we can generate this AM signal using the Multiplier IC AD633. So this is the functional block diagram of the analog multiplier IC. And here one input is applied between the X1 and X2, while the second input is applied between the Y1 and the Y2. And for the addition, we can apply the third input over here. So if we see the output W, then it can be expressed as X1 minus X2 times Y1 minus Y2 divided by 10 plus Z. Now here, let's say this X is the message signal while the Y is the carrier signal, that is equal to AC cos omega CT. And if we apply the same carrier signal as a Z, then we can generate the AM wave. So in that case, the modulated output ST can be given as MT times AC cos of omega CT divided by 10 plus AC cos omega CT. And if we take this AC cos omega CT outside, then we can write this expression as AC times 1 plus MT divided by 10 times cos of omega CT. So here we can say that the amplitude sensitivity, that is K, is equal to 1 over 10. So in this way, we can generate this linear amplitude modulated signal using this multiplier IC. Alright, so now let us talk about the second method, that is the square law modulator. So in this square law modulator, a nonlinear device or the circuit is used to generate this modulated output. And any device which has a nonlinear VI characteristic can be used as a nonlinear device. So as you are aware, a diode or a transistor has a nonlinear VI characteristic, and because of that, they can be used as a nonlinear device. For example, if we apply this input voltage to the diode and passes the diode current through the load resistor R, then the output voltage across the load would be of this form. So as you can see, it contains the second order, third order or even higher order terms. But when this input Vin is very small, then the higher order terms can be neglected. And in that case, we can consider this equation up to the second order terms. So here, because of the square law characteristic of the nonlinear device, it is possible to generate the modulated output, and hence this type of modulator is known as the square law modulator. So in this type of modulator, the input signal is the summation of the message signal and the carrier signal, and that signal is applied to the nonlinear device, and the output of the nonlinear device is then applied to the bandpass filter. So this filter passes only the required frequency components, and at the output of this bandpass filter we will get the desired modulated output. So this is the general overview of the square law modulator. But now let us understand how this modulated output is generated. So as I mentioned, even a diode or transistor can act as a nonlinear device, because if you are aware, the diode has a nonlinear VI characteristic, and the nonlinear relationship between the current and the voltage can be given by this Shockley's equation. So although the diode has this exponential characteristic, but during the certain region of operation, it behaves like a square law device. For example, when the diode is biased over here, and on top of it, when we apply the small input signal, then it can be used as a square law device. That means in that case, the input to the diode, that is Vd, is equal to VDO plus V in T, where this VDO is the DC biasing voltage and this V in T is the input signal. Now when we expand this diode current using the Taylor series around this VDO, then we can write this diode current ID as A1 times V in plus A2 times V in square plus A3 times V in cube plus so on. Now when this applied input signal is very small, then we can neglect the higher order terms. And when this diode current is passed through the load resistor, then the voltage across the load or the output voltage will follow this relationship. That means the output of the nonlinear device will be given by this expression. Now as I said, this V in T is equal to MT plus AC cos omega Ct, right? So here the output of this nonlinear device can be given as A times V in T, that is A times MT plus AC cos of omega Ct plus B times MT plus AC cos omega Ct square, that is equal to A times MT plus AC cos omega Ct plus B times M square T plus 2B AC times MT cos of omega Ct plus B times AC square cos square omega Ct. So if we expand all these terms, then we will get this expression. Now here, if you see these two terms, then they are of our interest, because these two terms will give us the AM signal. So let us write these two terms separately. That is equal to A times AC cos of omega Ct plus 2B times AC times MT cos omega Ct. Or further, if we simplify it, then we can write it as A times AC times 1 plus 2B divided by A times MT times cos of omega Ct. So if we compare this expression with the standard amplitude modulated signal, then we can say that here this amplitude sensitivity or K is equal to 2B divided by A. Now here, to get this signal, first of all we need to remove all other components, and that can be done using the bandpass filter. And to understand that, first of all let us see the frequency spectrum of all these terms. So here let's say the frequency spectrum of the message signal is equal to MF, and this message signal contains the maximum frequency up to B. Now if we see the spectrum of all these components, then it can be shown like this. So here this term is the frequency spectrum of the MT, while the frequency spectrum of this M square T will vary from 2B to minus 2B. Now when this message signal gets multiplied with the carrier signal, then the entire spectrum of the message signal will get shifted to the frequency plus minus Fc. And along with that, we will also get the discrete frequency component at the frequency plus minus Fc. And because of this term, we will get the frequency component at the plus minus 2 Fc. So here we are interested in this portion of the spectrum, and this portion can be recovered using the bandpass filter. And here, for the simplicity, let me just show you only the positive side of the spectrum. So here the bandpass filter should be designed in such a way that its center frequency is around Fc, and the pass band of this bandpass filter should be at least equal to 2B, so that we can filter out the desired spectrum. Apart from that, we also need to make sure that the passband of the filter does not overlap with any other frequencies. Or in this case, if you see, this Fc minus B should be much greater than 2B. Or from this we can say that this carrier frequency Fc should be much greater than 3B, right? So while designing the bandpass filter, we also need to keep this thing in mind. So in this way, using the square law modulator, it is possible to generate the AM wave. Now here, since the amplitude of the AM signal is very small, so we need to amplify it using the preamplifier and the amplifier. So this is all about the square law modulator, and in the next video we will learn about the switching modulator. So if you have any question or suggestion, do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.